All right. Well, thanks for everybody for coming out tonight. It's a little bit different from our normal setup. I'll get into some history, what's going on, and what the future is for I guess for both user groups. Let me go ahead and start this. So the subject tonight is going to be covering not just Jetpack Compose, but specifically composable UIs and why you may or may not want to use them. So one of the first things I like to do is try to plug the user group to try to get people, anybody that might be interested in speaking. I think Michael just suggested he might be interested in speaking on an upcoming topic. So I'll definitely be talking to you after the meetup tonight. And so that's my gross plug for tonight. Quick, a little bit about me for those who may not know about me. I've been running the Jaxnode user group since the start, and I've been both a web and mobile developer in my career. So I've worked a lot with JavaScript, TypeScript, React, C#, Swift, Objective-C, Kotlin, Java, and a lot of SQL as well. So today I was slinging a lot of SQL at my day job. I also have a blog where I write about this stuff. You can go to effect.io/blog. And the subject I talked about, I guess 2 months ago, I did a big post on that. I also have a YouTube channel called the Polyglot Engineer, where I also talk about this stuff. I have a GitHub page as well, where you can find a lot of this stuff. And I was full-time mobile development up until 2024, about May of 2024. And I'll get into the pluses and minuses of doing mobile development. So I just have one more thing I was going to add, that the opinions here are strictly my own, but they're based on facts. So you can take that how you want it. So let's talk a little bit about mobile development quickly here. So as I mentioned before, I did mobile development for a little over 8 years, and most of that time was developing on iOS. But I have done both iOS and Android, and those are the two primary platforms for doing mobile development, unless there's somebody here for Windows Phone. Okay, just checking. There's also a ton of different frameworks and platforms that you can use for developing for mobile. So one of the first ones that I think I became aware of that was called itself cross-platform was PhoneGap, which later became Cordova, which is the open source version of PhoneGap. React Native is another one. .NET MAUI, which used to be called, what they used to call that? Xamarin. Xamarin used to be the name of that. There's also NativeScript. There's now Kotlin multi-platform, and there's also a tool called Skip, which lets you essentially do the same thing Kotlin multi-platform does, but on the iOS and Swift side, where you can create Android apps from your Swift code. There's also something which I want to talk about when it comes to using these frameworks, which is what's the actual cost of building an app versus maintaining an app. So I think most of us know that been doing this for a while that 80% of development is actually maintaining existing apps. All right, so anyways, I was talking about what are some of the different options here for doing the mobile development. I talked a little bit about the cost of building versus maintaining an app. 80% of development obviously is maintaining existing applications. And something I was going to note is that as of 2025, don't try to raise money for a mobile app unless it uses AI. So
I guess uses AI is sort of a broad definition, right?
I guess you could just buy one of those domains that has .ai at the end of it, and you'd be good to go. But as this is a common complaint that I have from people I know that do mobile development, is that it's been difficult, not just if you try to get a job or have a job doing mobile development. It's also been difficult to try to start a company that's a mobile first company specifically. So I think the trend, at least for the last couple of years, is that with venture capital money, most of the funding or whatever seems to be going towards AI startups, and so that's where everybody's kind of like placing their bets right now. Not that long ago, it was mobile. Now it's AI. All right. So let me. All right. So some more stats. Here in the United States, about close to 59% of mobile users are actually using iOS or iPad OS. Android, it's 41%. So I think it used to be closer to like 50-50. But there has been a trend in the United States where more users seem to be kind of gravitating towards iOS. In the rest of the world, that is definitely not true. The rest of the world, about 3/4 of the world is actually using Android devices, and then 27% on iOS.
So
and
why is there such a big difference? Because people in the United States are richer
I
than the average?
I think that's part of it. I mean, there's definitely a cost with getting into the Apple, ecosystem. The joke has always been that Apple doesn't necessarily have the highest market share, but they have most of the profits, and so it's one of the things they're kind of famous for. But I think a more important stat is the one just below that, which says that about 64% of the world's population has and uses a smartphone. So over 5 billion people have a smartphone and use a smartphone. And that's one of the things that initially attracted me to doing mobile development, is that if you want like the most number of eyeballs possible, a mobile app, I think, is, or at least having a web app that works over mobile is kind of crucial. And I've seen some interesting statistics that, like, for instance, in countries like India, as an example, there's smartphone users that don't know how to read, but they still have like an Android phone and use an Android phone because they can use the icons and graphic symbols and stuff like that to kind of denote different things they need to do in the app.
I had a blind friend that was using it.
Yeah. So that's actually kind of miraculous. But that's what initially kind of attracted me to the mobile, was that there's going to be a higher percentage of people that haven't been use a phone than necessarily have and use a desktop. The next thing I was going to talk about is, I don't know how well we can see this. I'm going to minimize that. That is a dumpster fire floating down a flooded river. So the current Android OS is quite a bit different from what Google originally purchased, I think close to 20 years ago. All the original Android apps were actually built in Java. The original idea was that they were going to have a phone where you could write apps in Java, but the original design was quite a bit different from the smartphone enclosure that we're kind of used to now, where you have like one giant screen and a software keyboard. It was meant to be a little bit more BlackBerry-ish, the original Android phones.
Who did Google purchase it from?
I forget the name of the guy that started the company. He started the company and then sold it to either Larry or Sergey, because they thought that mobile was going to be an important thing for global users and for their own growth. He was, I want to say, maybe about 8 years ago, forced out of the company. The guy who started Android, for, I don't know if I want to get into the legal reasons, but he was forced out, and they had to pay him a lot of money. But he's the one that originally came up with the original version of Android. But when Apple did their famous keynote from, I think, 2007, showing off what the iPhone was going to be, they were like, "Oh, we're going to have to go back and change a whole bunch of stuff because people are going to want to use that. They're not going to want to use the original handsets that we were designing." So it changed a lot. after that. And so the operating system itself is really kind of, it's based off of Linux, but there's some things that are different from most of the Linux distros that I think we're used to. So one of the things that's different is that it's not POSIX compliant, which to me is a big red flag. But there's all kinds of other issues that are similar to that that I've personally run into problems with on Android. The current implementation is that when you are writing your applications, it actually they actually have a new file format called an AAB file format, which kind of is like a package that contains like the DEX files, and then what it does is it takes those DEX files and converts them into essentially into a executable code that can run on the device. And a lot of stuff is kind of decided at the Google Play Store level. So what you do is you upload your application as an AAB file to Google Play, and then when it gets distributed down onto the device, then they do some JITting, converting it into actual machine code to run on the device. That was not the original way that Android apps ran on the device, but it's all been optimized to try to get the best performance possible out of the device.
So what is DEX? So
DEX essentially is the when you take your say your Java code as an example, and it gets converted into bytecode. The DEX files are the file format that Google came up with. So essentially take that bytecode and it's turned into these DEX files that then can be optimized for individual. It's like a second stage after the initial compilation. At least that's my understanding of how it works. All right. So as far as like creating layouts for Android, there's a joke I saw one time about Java and XML. Like Java developers love XML. So all the initial like layouts, the way you did layouts for Android were all based off of XML files. And there's one of the things that's nice about Android Studio is that it has a way of being able to preview those layouts. But one of the things I think that was really important for mobile development was back in 2015, Facebook, now Meta, introduced React Native. And so React Native essentially lets developers write applications in React that run natively on the device. And they have a kind of like, it's not called a bridge anymore, but it used to be called the JavaScript bridge, where essentially it would take your business logic and kind of create a bundle out of your JavaScript. And then all your business logic essentially ran to that. But all of the actual components, the way that the views worked were all native. So when you pull up let's say like an image as an example, you're actually using the native UI image on the device if you're on iOS, and then you're using image on Android. And so essentially it's an abstraction on top of the existing operating system where you can kind of leverage the native UI elements. And so the thing that was kind of groundbreaking about React Native is that now, as the developer was writing their application, they could actually do hot reloading. And so you could start making changes to your code and see the changes to the UI instantaneously, which is something you were not able to do on iOS or Android. You always had to compile the application and then run it in order to be able to see your UI changes. And so that was pretty revolutionary. There's also some other things they did with React Native where you could actually, after you delivered an app to the App Store, you could actually do a bundle reload after the app has already been installed on the user's device. And I forget what the name of the technology. There's a company that I think Microsoft bought that allowed you to kind of do that. But they've since canceled that project. So I don't know how React Native developers are doing that now. But we were using that. I used to work at a company called Bill.com, and we had a React Native application, and we would do sometimes we would do 3 releases in a day. So that's one of the things that React Native allows you to do that is just not possible to do with the existing native frameworks. And so then in 2019, Apple introduced Swift UI. 2019 was the last in-person WWDC. WWDC is the big conference that Apple has every year. And for everybody remembers, 2020 is when COVID showed up. And so they stopped having in-person events at Apple after that. But I was actually at the 2019 WWDC when they first announced Swift UI. And so Swift UI uses a lot of the same metaphors that are used in React Native. And so just like with React, where you can kind of build these components that you can kind of like encapsulate other components inside of one component and do like hot reloading. With Swift UI, you kind of build your UIs very similar to the way that you do with React Native, which it's all component based. And they even have a feature that doesn't work quite as well as hot reloading, but you can start seeing your changes in your application as you are typing your code. So that was a big improvement from the Apple ecosystem. And then that same year, Google announced Jetpack Compose, which is going to be their version of a component-based UI framework. And they officially went 1.0 in 2022, which was the same year that while I was at Bill, we decided to rewrite both of our native applications using Swift UI on iOS and Compose on Android. But they had just went 1.0 on the Android side. So we definitely experienced, I think, more pain on the Android side than we did on the iOS side. But they're both relatively new UI frameworks. So something about component-based UI is that just like with React, it lets you build these reusable components. React really kind of pioneered this. And so something that's also pretty common is that you have different properties and behaviors that you can define for your components that can be bound to those components. And one of the patterns that's very popular on the Apple side, and also now with Compose, is the MVVM pattern. So is everybody here familiar with MVC, the MVC pattern? Yes. Okay. I'm sorry?
I'm not familiar with the MVVM though.
Okay, so we'll talk a little about that. So MVVM stands for the model view model. And what that basically means is that instead of developing or building your application out as a separate model, separate view, and a separate controller, you have a model, you also have a view, but then you also have an object called a view model. And the view model is basically how you administer your business logic and handle state is going to be through the view model. The views and the models themselves are actually supposed to be very simple and serializable. So the other thing that's good about Compose is it's part of Jetpack. So one of the things that Google has done, I think was pretty important, is that they realized at some point that all the different people that make devices for Android, really what they want you to do is just to go out and buy a new device whenever a new version of the Android operating system comes out. Apple's a little bit different about that. Apple, I think, is more about kind of locking you into the device and then paying for services. And so Apple, generally, you can do operating system updates on an Apple device for far longer than you typically would be able to do with an Android device. So there's some Android makers that are a little bit better than others. Like Google has the Pixel phone. I own a Pixel phone. And they generally do a pretty good job of doing updates at least for a year. I'm sorry, 5 years? The one I have doesn't have, I'll have to check and see what version it is, but I think it's like one version back. It's not like the latest version. It's a Pixel 6.
Oh, no, it definitely still on support.
Okay.
And it should have 5 years
All right. Well, like I said, Google does a much better job at this than other device makers. I think Motorola generally is pretty good about updating their devices. Samsung's horrible about it. So it's like you pretty much are stuck with that version of the operating system when you buy a Samsung device. But here's the nice thing for us. So if you're using Jetpack, one of the things that's great about Jetpack is that generally when Google releases new functionality for Android, rather than tie it to a OS update, they'll a lot of times will just tie it into Jetpack. And Jetpack essentially is a library that you can embed into your applications. And so when updates for that library come up, all you have to do is update the library in your application, and then your users can start taking advantage of these new features. And so Compose is an example of something like that. I forget like what the I forget which version of the Android operating system that they go back to, but it's like you can run Compose on some pretty old versions of Android. And then the other thing that's nice is that they've been working on this platform called Kotlin multi-platform. I don't think this is a Google project. I think it's more of a JetBrains project. But one of the things that JetBrains is actually they're the creators of Kotlin. And one of the things they've done with Kotlin is that you can target not just Java, but you can actually target different platforms. So they have like a web target that you can use. So you can write your applications in Kotlin, and then it will, I believe, create WebAssembly that you can then use in order to run stuff on the web. And then they have also targeted iOS, and they have targets for desktops as well. So I believe that they're targeting Windows and Mac OS, but their targeted support is still like, I don't know, alpha or beta for like the desktop operating systems. And they just went 1.0 with their iOS support. So I have not tried to build an iOS application with Kotlin multi-platform, but I'm always leery of anything that just went 1.0. Like I said before, like we started using Compose at Bill right when it was 1.0. So that has its own challenges. So this is kind of an example of what a view looks like in Compose. And so essentially all you have to do is define a function, and you just use a composable attribute on the function. And then you can pass modifiers here. And so in this case, we're using another Compose element called card. And then we're passing in a modifier to it saying that we want to add padding of 16 best density pixels. And then inside of that, we're putting in some text saying hello Compose with its own modifier. And so that's literally how simple it is to create a view with Compose. So something that's probably a little bit different is that, previously when you're building views in Android, you would create an XML file to kind of define your view, but then you'd have to bind it to an Android activity or class. But now all you have to do is just assign this composable attribute to your function, and that will make the function essentially a view. One of the downsides here is that you can't really inherit from other components, but you can create components composed of other components, which is probably preferable anyways. And then the return type is going to be something called a unit, but you don't have to specify that. So the basic building blocks when you're building out your views and your UI, they have columns, rows, and boxes. And this is very similar to B stacks, H stacks, and Z stacks in Swift UI. So columns basically let you stack child components vertically. Rows let you do it horizontally. And then boxes, you can stack your components on a Z axis. And so anybody that's worked with Flexbox in the web, this is very similar to the way Flexbox works. They also have a scaffold component, which you can kind of use to hold your UI together. You can add a top bar, bottom bar, and then also a floating action button. So that's something that's very common in Android. Like for instance, if you need to create like a new record, as an example, it's very popular to have like a little floating action button where you can do that. And that's part of the scaffold component. And this is also good for keeping your components inside of a safe area.
I didn't understand the floating button. Why do you want it? What is the floating button? It moves around or just?
You can move it around, yeah.
So
I've
what?
been using Android for years. I have no idea what you're talking about.
Oh, really?
Remember on Gmail, they used to have that little action button. You know what you're talking about?
Yeah.
When you scroll,
I
it stays. where it
Yeah, I
is.
personally don't like it. I haven't seen it in that many Android applications. But there's a framework I used to use that we used to use on both iOS and Android, and we had a floating button that we used on both Android and iOS, which is a little bit weird.
It's kind of like that little edit button, right?
Yes, exactly. So this is kind of an example of how you could lay something out with Compose. So if you look at this example here, we've got a row, and then inside of that row, we've got an image, but then we have a column inside that row that has the two text fields on top of each other. And so this is the way that you can kind of create like a card or an arrangement pretty easily using Compose. And then modifiers. Modifiers are essentially how we kind of control properties inside of a Compose component. It's a declarative configuration. And you can kind of use these to kind of change the appearance, the layout, the behavior of a component. You can also chain these together, and the order of which you chain these functions together actually changes the way sometimes the way a component looks and also the way it behaves. And so the order of the way that you call these functions actually does matter. And this is actually identical to the way that works on Swift UI. So when you are doing the same thing, calling different functions on a Swift UI component, the order in which you call them also matters. And then as a pattern, this I think would be commonly referred to as a monad. Douglas Crockford famously gave a pretty cool presentation on monad. So if you're interested in that, I highly suggest watching. I'm sorry?
Who did?
Douglas Crockford. Douglas Crockford wrote a book called JavaScript, the good parts, because there's obviously a lot of bad parts to.
Or a pamphlet.
Yeah. It's not the biggest book, but it's actually a pretty good book.
Well, compared to the other books in that series,
Yeah. It's an O'Reilly book, if I remember correctly, and a lot of the Riley books are like, they're pretty thick.
well, they're good parts. There's a bunch of good parts. Books.
Oh, okay. All right.
So which language is the biggest?
I don't know. But
Probably Ruby, I imagine. Maybe.
I think many different people try to explain monad to me in many different ways, and it never made sense to me.
That's one of the points that Crockford makes in his presentation. It's like once you understand what a monad is, it becomes impossible for you to describe what a monad is to anybody else. Exactly.
The problem you run into is like when you're learning about it, you're like, wait, I've been doing it this whole time, and you get confused.
Yeah. So then another aspect of using Compose is state. And so it actually has its a runtime that uses to keep track of the state using remember savable. And then remember simply just keeps track of a value, but remember savable actually keeps track of the state over re-renders. And so that becomes pretty important. Like if you have a UI that you're building where you want to rotate the device on Android, essentially every time you change the aspect of your device, it actually, I believe, kills and redraws the UI every time that it does that. And so if you want to maintain state over that, remember savable becomes kind of important. And so an example of how you would use this is that you just define some value, but instead of saying equal to remember, you say some value by remember savable, and then you specify immutable state of whatever type it's supposed to be. So in this case, it's a string for that example. So some of the other basic components, they have a text component, text input, checkbox, switch, radio button, sliders. All the input components should be tied to state. The image component that works with static images or over a network. There's also one that you can use from a framework called Coil called ASIC image for if you want to essentially pass a URL that you want the ASIC image to load. It'll do that asynchronously, so you don't have to worry about blocking your UI. They also have a canvas that you can use if you want to draw like basic shapes, like draw circle, draw rect, draw oval, that sort of thing. And then they also have lazy lists. And so if you look at a lot of mobile apps, they're generally, a lot of them are like list apps, whether you're using your settings or you're using, let's say something like Facebook as an example. One of the things that they'll do is, you have essentially just a list of, either posts or pictures or components. And so they do have this lazy column that you can use for loading this up. And believe me, it's a lot easier than using the recycler view, which is the way that you've done that in the past on Android. Navigation, there's an Android X library that's a specific navigation library for Compose. It allows you to create routes. I have an example of that working tonight that we'll take a look at. But it uses something called a navgraph builder, such as a nav host to be able to host your navigation controller. The routes are defined in a composable function. So if you've used frameworks, let's say like Angular or like React navigation, you're probably familiar with how you build out navigation controllers with that. And so this is very similar to that. They do have a new 3.0 navigation library, but that is in alpha, so I wouldn't suggest using that right now. So as I was talking about before with MVM, that is the preferred model for working with Compose. Generally, when you're creating your models, you'll use how many people here, how familiar is everybody here of Kotlin, the Kotlin language? A little bit?
I've been frustrated by it.
Okay. All right, so we'll talk a little bit about Kotlin tonight. But one of the things that's actually kind of neat about Kotlin is they have this concept called a data class. And a data class essentially is just a very simple class. It's usually if you need to be able to serialize, deserialize data, it's a good type for that. And the best way I can think of describing that is like a structure, in other language. So in C,
Java now supports that. I mean, now Java has that as well.
a data class or a structure?
It's called a record, maybe.
Okay.
What it's called. I haven't used it much.
Yeah. So they have this concept of a data class that you can use for creating very simple.
Python has a data class. It's called data class.
Yeah. And then views, like as we've seen so far, are made up of composable functions. And then the view models are generally defined by a class. So a regular class that you use in Kotlin or Java, that's how you create your view models. And then you store your state in the view model, using something like the mutable state store as an example. And then if you're making, network calls, the library I traditionally used for doing all of my HTTP calls, my HTTP client was OKHTTP. But there's one that's written in Kotlin that I think is starting to become pretty popular called Ktor. I don't know if I'm pronouncing that correctly or not. So the demo tonight, I actually use Ktor instead of OKHTTP. Then some people, a lot of mobile developers love GraphQL. I'm not a super huge fan of GraphQL, but the company I used to work at, Bill, like we redid everything on mobile and web in GraphQL, and we were using Apollo specifically to do that. You can also store data locally using SQLite. And there's also frameworks like Firebase or Amplify if you want to work with your data that way as well. And so, yeah.
I think only client developers like GraphQL.
Yeah.
Only people I've ever met that actually like using it, or maybe mobile client.
Well, the one thing I will say that is nice about it is that it essentially eliminates a lot of boilerplate. So if you are essentially trying to retrieve the data that you need or mutate using GraphQL, one of the things that's nice on the native side is that it actually will generate the code for making all those API calls. And so it becomes very simple from that point. But the problem I have with GraphQL is more on the server side because one of the things that it's supposed to solve is that it allows you to take multiple different endpoints and kind of combine them together, no pun intended, into a single endpoint that you can use. But I personally have seen problems with GraphQL where it's trying to do things that have been a lot better if you try to take two different sets of data and then join them in a database and then give it the data back that way. But that's a whole nother topic. So with that, let's go ahead and do a quick demo. So I'm going to open up Android Studio. And so I don't know how well, can everybody read that okay?
Yep.
All right. So let's take a look here. This is my Rick and Morty demo. Let me open up. I have another one.
Is this is this code gonna be online somewhere?
It is. It's already up online, and I will share the links for that after the meeting tonight. So this is an app here that I'm calling the kitchen sink app because I tried to throw as many things in there, including the kitchen sink as far as the UI goes. And so if you're not familiar with typical Android project structure, generally you have a app folder where most of your code for the app belongs to, and then there's generally a main folder. And then you can go in here and you can go to this Java folder. And even though it's called Java, I don't have any Java code in here. It's all Kotlin code. And if I come here, there used to be two files that were probably standard boilerplate for Android application. There was a main activity and then a main application. And this version that I just created for the example tonight, when I went to go scaffold this out, I just had a main activity, didn't have a main application anymore. So I don't know if that means you can add the application or not, but this is what the main activity kind of looks like. So if we take a look at this, this is actually a very small file. All it's doing here is creating an activity. So generally, if you are creating like a view in Android, you would create an activity. And then the view itself, you just basically, you set that inside of the set content. And so if you look right here, we can see that we've got this kitchen sink screen. So I'm going to go ahead and open that. Go to implementation. All right, so this is our kitchen sink. And one of the things that we'll see here that I like about this, I'm going to switch to a different mouse here. All right, so if we start scrolling through here, I apologize for kind of going through this quickly, but if we look right here, we can see that on this one private function here, I've created a preview. And one of the things that's great about Compose is that you can use this preview modifier, or attribute. And then if we want to see what that looks like, I can come over here, hit the split view, and it actually will render this. So you can see what the UI looks like as you're going through and working with the UI and changing. And then I also have a simulator set up here. So I'm gonna go ahead and run the simulator.
So that doesn't require a simulator?
Nope. No, it's just doing a preview. So you don't have any functionality here that you can use. So it's a little bit different from the way this works on iOS. iOS also lets you preview your views, but you can actually modify them. Or you, like, for instance, if you have like an input attribute as an example, you can actually tap on that and without having to run it in the simulator. So here's a simulator. And so in here, what I've done is I've created this is, I think most React developers probably recognize this when you do like a boilerplate, like React app, it generally has like something that tracks the number of clicks here, but I also have an input where I can type in my name. And then if we look at this, I can even put in an email address. And we can see here that it's actually using state to keep track of that and bind that into this string right here. But we also have in here, right, is that we've got a checkbox. We also have a little,
Slide.
yeah,
No, it's not.
yeah.
I mean, this is meant to look like material UI.
This is actually, so I am using a material theme. And so that's another thing that's nice about this. So Michael has given a pretty interesting talk at Jaxnode in the past on design systems. And one of the things that's pretty nice about Compose is that if your organization's working with a design system, it makes it very easy to work with design systems because you can create themes and component libraries that you can then reuse. So you have all that capability when you're using Compose. All right, so I'm just going to close that preview here, but just kind of show kind of like how this stuff is kind of defined here. So if we look at
Is this where if you had rotated the device, if you didn't use the save?
yes,
it would-
this will still work. So for instance, let's just test it out. Yeah, so if I come here and I rotate the device here, so that they rotate
No, it's above.
snapshot. I'm sorry?
It's above that reset, the two devices to the left.
Right here. Okay, I see that. Yeah. So there you can see that it's still maintained the clicks. I can rotate that back, and it's preserved all this. So you don't lose that.
And is that because you're using the?
I'm using the remember savable. Yeah. All right. All right. So let's show the next one. This is why I couldn't see it. All right. So this next one, actually, let me kill this guy. Bear with me a second. All right. So, oops. So this is my Rick and Morty demo. Is everybody here familiar with the TV show Rick and Morty?
What?
Okay.
Someone makes me think of pickles.
All right. So this app is a little bit different. So this is my main activity in this app. And so here I'm setting the content around the theme for my Rick and Morty app. And then in my Rick and Morty app, one of the things you'll notice here is I talked about the navigation controller. And so what I've done here is I have defined a nav host. And then inside of that host, I have two routes that I have set up. I have one that is a list. And then I have another one that is a detail where you can pass a parameter for the ID. And then down here is my actual implementation of those routes. And so I've got one here for the characters route. And this is going to be my list with all my characters in it. And then I have another one here that is my detail. So when I go to click on a specific character, I can get a detail view and see what that looks like. And so I set that up essentially right here in the main activity. You don't have to do it that way, but that's the way I did it for this example. And as I mentioned before, you can create, these are my view models. And so these are classes where I'm keeping track of the state and managing that in here. And so I have some functions in here that I can call on that. So if I need to refresh, I can call that. If I want to go to like a next page, I can do that. And the same thing with the detail here. This is essentially just a wrapper for maintaining your business logic and maintaining your state. Then I have these DTO. And these are the data classes. This would be like a struct in Swift. And this is just a simple definition of what my models are going to look like. So I've got one here for my name reference. I've got one here for my UI state. Another one here for the character response, and then I have another one here for the character. And then I have components in here. So for instance, like for my detailed body as an example, if I come here and open that, let's do a build and refresh. So I apologize, this is kind of hard to see here, but this is kind of giving a.
So you're refreshing the sample?
Yes, I had to do a build so it could actually do the refresh, but let's actually take a look and see how the whole app works. So I'm gonna go ahead and run that. All right. Sure what to do with this.
So like the simulation will give you kind of runtime errors as you click around.
This will be interesting to see if my internet connection is working. So what this is doing right now is it's actually trying to go and retrieve.
Data.
Yes.
Again, until it's loading, I saw that they were in one of those structs, there was a ref. So like would that be similar to, say, like in React Native, you would use a ref if you didn't want the state to change somehow and you didn't want things to re-render? I was just wondering.
No.
No.
This is completely different. Yeah. So this is what you're referring to is that like one of the things you can do in React is you can create, let's say, like a forward ref or just a ref in general. So that, for instance, if you are trying to control something from, let's say, like a native control as an example, there's certain functions you want to be able to call on that. You can essentially tie it to a like a referenced variable, and then make those calls and stuff like that. This is just like a data struct. I'm going to kill this and try run it again and see what happens.
You may have mentioned this earlier, but is there a Kotlin version of like Swift data that instead of using the DTO, it's kind of defined your like local data to make sense?
So I'm so you mind ask me that again?
Yeah. So you defined your DTOs like models, but there's like simple struct, right? And,
yes.
Like you say in Python sometime, like Swift has Swift data where you store, your data on device, and then you can see.
I see what you're saying. Yeah.
And it is like, it's essentially like in Python, there's like SQL model that's like it's like your Pydantic and your table structure in one, kind of like an active record, right?
Yeah.
Is there a version, like, is there a Kotlin model definition that's like defines your data and your kind of.
I do not use Android, or I don't do enough Android development to say. I have one Android application that I'm currently working on right now. It's a React Native application. They do have Swift data on iOS, and that's essentially is very similar to another technology that Apple had for managing persistence on the device. I'm blanking on the name of that framework, but essentially they both, I believe, use SQLite under the hood, or at least you can have it use SQLite. But then SQLite is just a native part of Android, and so one of my favorite things, or my favorite jokes about developers is that everybody just assumes that software engineers don't know how to write SQL. They need a DBA to do that for them, but I've been doing it my entire career.
That's why we read ORMs though.
Yeah, I'm not a big fan of.
It's the ubiquitous common denominator that everybody is accessible basically to people that are not technical and technical, so that's what keeps it alive for so long.
Yeah,
but I guess you can be very use just the basics, so it could be very sophisticated.
yeah. So
is there a way to like open up a network tab to confirm that the network was fired and came back?
The closest thing to that would probably just to be to look at the logcat. So Android, yeah, they have a, let's see here.
I've definitely not turned off a loading spinner before, and even like a request would finish, but
So this is actually very similar. On iOS, there's a console that you can also look at where you can look to see if there's things that are failing here. This may not be working because this may be blocked on the network here, but it's definitely looks like we're getting a failure when it's going to call the API. So this channel is unrecoverable, broken, and will be disposed. So there's something hanky going on here. But here's the good news is that I have all this source code up on my GitHub page. And so anybody here that wants to play around with this and see what it looks like, we can do that. I probably should have brought my, I have a Pixel phone that I have this app installed on where I probably could have demoed this tonight, but this is does not appear to be working. But we can at least take a look at the previews to see kind of like how things are composed here. So let me just.
So what does it have what does it do with Rick and Morty? It gives you the bio.
Yeah, so what it does is the app does is it gives you a list of all the different characters that are in the every season of Rick and Morty, and so it's actually pretty funny when you actually go to take a look at the app. That's why I'm disappointed it's not working. But you can go and you can click on the character. It tells you what what species they are, what sex they are. I'm a big fan of that show, so the characters are pretty crazy. But yeah, it's kind of because they have like different versions of the same character. Like if you've watched the show, it's like they'll like do clones of some characters, and the clone's not quite right, and so it's a lot of fun. But yeah, it does not appear to be working. So I'm gonna go ahead and try to minimize this window here. There we go. And I'm just gonna take a look here. I'm gonna kill the simulator here. All right. So let's take a look at the character screen. And I don't think I have a, what do you call them, character row. Let's take a look at the character row. So if we take a look at this is kind of what each row would look like. And if we let's see here. So we can see here, this is the preview of it. So right here, we've got an async image that's set up to be 64 density pixels. It's also got a content scale crop on it. And yep.
So a preview is kind of like a console log. It's like a visual representation of what you're calling out. You could say, show me this. Show me this function.
Yeah, it is kind of like Storybook.
It's kind of like Storybook. The previews in Xcode and Studio.
Yeah. So you can come over here, you can select different parts of it here, but you can see here we've got the column here that's defined, and then each column has a text field in here, and so we're just displaying the text here of different. Oops, let me just click on. Whoops, I didn't mean to do that.
Storybook's the testing.
Yeah.
So.
Well, I mean, as I say, it's like the way we use it. So we use Storybook at my company now, and the way that we use it, we do use it as a way of testing components, but we also use it as a kind of like a catalog. So we can go through and take a look at all the different components that we have in React, and then see what they render out. We have test data that we can use and do that with. So I'm a
Use it for React Native.
Yeah, no, we use it for React, but I have my previous company, we did use it with React Native. But
is that possible? You can use that with React Native, and you can get sort of an Android, iOS, and web.
It's going to work differently because like
Is Storybook, you mean?
Yeah.
Yeah, there's a React Native version.
Oh, wow. I didn't know that. That's cool.
but anyways, so you can see here that this is very simple the way you compose like a component using Flexbox as an example, where you can do like a card and that's that sort of thing. I want to show the networking and how that works because I thought that was kind of interesting. This is the first time doing this. This demo was the first time I'd had a chance to actually work with KTOR. I don't know if I'm pronouncing that correctly or not.
The networking was what screwed me up when I tried to do Kotlin in the past with widgets.
Yeah. So if you look at this example, this is actually quite simple. So there's two different API calls, one for getting a list of characters, one for getting a specific character and passing in an ID for that character. And so it knows how to parse the URL when doing that. And then I am just creating a singleton of the HTTP client. This is how you do a singleton in Kotlin. And then it's just referencing that client. And then all you have to do is call this implementation and you can use that to retrieve the data. That's of course, if your network is not blocked for some reason.
Did your kitchen sink one have a network request?
No. Well, it might have. I think it did have one at the very bottom. I wasn't able to scroll down to it. It had one at the very bottom for pulling back an image. So I'll show that here in a little bit. But then see here. So I've got an interface here for my Rick and Morty API. And then we've got one here for the character detail UI state. But this is just a kind of a simple list detail type of application. So I'm disappointed that it's not working tonight, but we can talk about that. Since I'm looking at some Gradle files here, I'm going to go off a little bit of a rant on Gradle. So Gradle is the build system that I think is probably the most popular build system for Java applications. And
in the Android, it's like the default, right?
It's the default, yeah. In fact, I don't know of a way to do builds without Gradle. But it's like every time I go to scaffold out a new Android application, there's always something that throws me for a loop. Either the previous version of Gradle does not work the way that it was supposed to. I get build errors. I have to go through and Google stuff for an hour, or I guess ChatGPT, to try to figure out the correct way of configuring the Gradle files. But in Android applications, there's two build.gradle files. In this case, we're actually using a Kotlin-based version of that, since we couldn't complicate things enough with just using Groovy versions of Gradle. Yeah, they're migrating to Kotlin. Yeah, so this is the kind of like the root level of that, where we have some plugins defined. But then if I go into the app itself, there's also another build.gradle file, just so you don't get confused. There's two build.gradle files here, and you can see here that I am using a couple of dependencies. And so that async image is an example. I believe that is part of Coil. And previously, you'd just be able to specify in your implementation, you'd specify in a string the name of the dependency you're using and the version of that dependency. But that was getting too simple. So they decided to add a TOML file. So now there is a TOML file. If you go into the Gradle folder, they have this libs.version.toml. Yeah. And so here you define the version and a separate section of the file. You define your libraries in here. I added in Coil Compose and the KTOR for being able to do essentially the networking requests. And I also added one in here specifically for doing the serialization. So one of the things I did not talk about, but I did show, is if we take a look at the data transfer objects, this is an example. I've got this character one as an example. You'll see there's a serializable annotation. That's actually from that library I imported. And that's what's letting me take the data that's coming back as JSON and convert it into an object that then can be used inside of Android. Most systems have some way of being able to serialize and deserialize data like this. And then I'm trying to think what else I was going to show. So show the TOML file. Oh, this is the other thing I was going to show. So almost, I mean, every Android application has a Android manifest.xml file. And so much like on iOS, where you have to, the user has to allow or permit the application to, let's say, user location as an example, or receive notifications. The way that you specify that in Android is use one of these use permission tags. And so for the making network requests and stuff like that, you have to specify like an internet permission for access to internet, and then another one for accessing the network and the network state. And so that's one of the things that's a little bit different on the Android side than on the iOS side. And that's basically
On the iOS side, do they have like a manifest as well of some sort?
they have a plist file where you can configure a lot of things. There's a file called an info plist, and a plist is just another XML file, just that it's Apple's version of XML that does not actually follow the correct XML specification. That's another rant that I have. But yeah, so one of the differences there is that if you're using Xcode as an example, let me open up Xcode so we can see what that looks like. I may have an app here that we can take a look at. So this is my dog ears app. So if we come here and take a look at this info tab, you can see I have all these different keys here that I've defined, but it's actually stored in a plist file on the iOS side. So I think they make it a little bit easier on the Apple side for being able to manage those. But that's essentially how that works. Let me go back to the slides here. Whoops. All right.
David,
Yes.
quick question. If you had to create a new app today, would you use either Java, Kotlin, or React Native?
So for Android, I would definitely do it natively using Kotlin. And there's a couple of reasons for that. One of the reasons why I kind of touched on this at the beginning of the presentation, where I was talking about the 80% of your application is maintenance. It's not, greenfield development, unfortunately. So what I have found and what other studies have found is that when you are doing, let's say you build an application using one of these cross-platform frameworks, let's say like Flutter or React Native. I personally experienced this with React Native. Is that it's really easy to get started and to start building out a cross-platform application very quickly using that. But the pain comes when there's a new version of the React Native framework, and you can't do a build in Xcode unless you've upgraded to so-and-so version of React Native. Now you've got to go through and modify, you potentially may have to modify some Ruby bundles. You may have to modify, upgrade different modules, because the modules that you're using in React Native are not just JavaScript modules. If they're using any type of native elements, then they also have to have the Android and iOS baked into those modules as well. And sometimes there's incompatibilities with those. And then I personally, like with some of the like more popular like React native libraries or modules that I've used, there's been things like, well, you have to upgrade to this version of that module in order for it to work with the current version of React Native. And then the way that you define, let's say, like React navigation was a perfect example of this. Like we had to, at the last company I was at, we had to redo all of our React navigation in the application because it was not compatible with the current version of the framework. So one of the things I like about the stuff that I've written for iOS and Xcode is that I have applications that I've written in Objective-C. I can open them up, push the run button, and they just work. So to me, that's a big deal. So I don't like things that just break for no reason whatsoever. And I've had that happen with React Native. On the Android side, I'm to be honest, I am not a guru with Kotlin. Most of my Android development has been actually writing Java, but the default language for starting a Android project, I think since 2019, has been Kotlin. Kotlin it's a newer language. I don't want to say it's better than Java because that might offend some people in the room, but it's definitely it's a newer, more modern language. And so like for instance, you can define a variable without having to specify a type, which is something like you'd be able to do in other languages, let's say like C#, because in C# you can just say var in front of one of your. You can do it in Java. What keyword do you use to do it in Java? Var? Oh, they've added. Okay, I apologize. I've not kept track of all the latest.
Especially it's a lot more concise, I guess, less boilerplate.
Okay, this is showing how out of date I am with Java. So let me ask this: can you create properties now in Java? Do they have like a property type?
Not that I can recall, but I have not been using Java for quite a few years myself.
Yeah, okay. So I just for the record, it's like most of the Android development I've done in Java. I personally like Java a lot. But if I was starting a new project from scratch, I would use Kotlin to do that because you're going to have a lot easier time with support. And also, if you need to bring other Android developers onto the project, I think at this point there's a lot more Android developers that are more experienced with Kotlin than they are with Java. But that being said, one of the things that's really nice about Android Studio and JetBrains is that you can actually take a Java class, as an example, and you can cut and paste it into Android Studio, and it will automatically convert it into Kotlin for you. And the way that Kotlin and Java work together is actually quite miraculous. It's like they really do work well together. So it is.
So
but still, the fact that you can cut and paste, I can literally cut a Java class, go into a Kotlin file, paste it into the Kotlin file, and it will convert it into a Kotlin class for me.
Well, but that's just the editor.
I'm not sure how it's doing it, but it's still pretty cool. So I think that's pretty cool. So the company I worked at 2 companies ago, I worked for a small kind of boutique mobile development shop out in Ponte Vedra Beach, and so we were a small team. We had to do both the iOS and the Android version, and so I had other developers I worked with who were better at Android than I was, and so they adopted Kotlin, started using Kotlin right away. And then whenever I had to do something in the application that needed my assistance, like something that only I could do, then I would do it in Java just because I was more familiar with Java than I was with Kotlin. But if I was starting a new project from scratch, I definitely would do it in Kotlin. I'd go through the pain of actually, getting better at the language. So there's all kinds of stuff that's pretty cool about Kotlin. Like they have coroutines where you can essentially do things asynchronously fairly simply. Like a lot of languages have adopted async and await paradigms, and then like Rust does async and await, Swift does async and await, JavaScript does async and await. But they use coroutines in Kotlin, and it seems to work pretty well for that community.
Awesome, thank you.
No problem.
When you go to like your Android Studio, there's like a way to import projects. So if you like close out of all of them, it'll give you that little menu. And then once you're here, you can hit the ... in the top right.
Top right.
Next to clone repository.
Yeah.
And you can do import Android code sample. And then it gives you like a searchable thing, so you can put in like compose, and it'll load all. So like that Jetnews app is like a compose thing. And so it's like all of their like online samples, and it kind of gets you set up. And I think you can do the same thing to open back up your project,
Okay.
and you click on one of them. You can click on file,
On file. Yep.
and then new, and then import sample. Yeah, I think it gets you to this
Ah.
page.
Okay. So I'll just include it into your project.
This, I was using this because I was trying to make a widget and I had no idea. And it got me started with like some mock data, but I couldn't figure out network handling. So
Okay. Well, I think if you've done React development, I think this is actually not that difficult of a transition to do Android development, especially if you're using Compose, because a lot of the paradigms are the same.
I didn't have troubles with the displaying things, getting things to look pretty.
Yeah.
I couldn't get the data alone. So I'm interested to see what your project's like. So unbreak my thing.
Yeah, I'm not doing a lot of mobile anymore. Up until 2024, I was working on a contract. I've been off that contract for over a year, and so I try to go back in and do just on my own, just so I can stay fresh and up to date with what's going on. This presentation is actually a good excuse for me because I've been wanting to get more familiar with Compose. I've used Swift UI and I've used React Native and React just in general. And so it's kind of neat to kind of go around and play around with these examples.
Do you like that it's dynamic typed?
I'm sorry?
Do you like that it's dynamic typed?
Well, I mean, Kotlin is not really, it's statically typed. Well, I mean, so technically JavaScript is dynamically typed, and I like JavaScript a lot. It'd be bad if I ran a JavaScript user group and I didn't like JavaScript, but I like JavaScript a lot. But at the company I work at now, we're using TypeScript, which essentially kind of fakes a statically typed type system on top of JavaScript.
All lots.
Yeah. So at the end of the day, just well, it depends on how you have your linter set up.
I
So
just found like a new function. Not related to the talk, but it's awesome.
so as far as the slides and stuff, I'll post that all up on the meetup groups. But I've got if you go to the Jaxnode-UG GitHub page, I have two apps that I pushed up there. One's the Rick and Morty app, which you can download as long as you don't have a restricted internet connection, I guess, and be able to use. And then the kitchen sink app is there with all the different components and stuff that you can use in your application. All right, well, that's about it for the presentation. All right, I don't know when Jaxnode's going to be meeting again. I'm still trying to line up a regular meeting place. There's a couple of people that have offered meeting space. Kaiser University, I've talked to them a little bit. They haven't officially offered me a room there, but that's nice because it's easy access to get in.
You need to go through some approval process that Brandy can tell you what she had to go.
Yeah, I'm actually talking to the woman that's in charge of that now. So there's some paperwork I have to fill out in order to be able to use the room. The big thing that they want is if they have any students that are interested in attending the user group, they want them to be able to. I'm all for that. If the students are interested in coming in and watching that, I'm all for that. And then I've also was approached by HashRocket to have the meetings there as well. It's a little bit smaller of a space and it's out at the beach, but we might have been there as well.
Yeah, or fast tracker about others.
Yeah. Okay.
What about taking your motorcycle?
Well, the Kaiser, the one thing that might be tricky about Kaiser is that they have a overhead projector they use for you can hook up to
The one I climbed on yesterday.
the one you had to. There was some work that went into actually getting it to work correctly. And so what a lot of the user groups that meet there have been doing is they've been bringing their own projector. And so anyways,
Anyone wants to donate a projector?
well, I don't know about donating a projector, but we'll try to figure out how to make that work if we meet at Kaiser.
It didn't want to do that yesterday after we finished.
Well, I know he was having problems. The guy who's doing the presentation yesterday, there was like a dongle that he was a HDMI connector, and he plugged that in, and then initially it wasn't working. He was trying to figure out how he could connect to the projector using that, and eventually he got it working. But it wasn't as simple as just plugging a cable in. And
I thought they were talking about trying to get the.
that was problematic too. Yeah, trying to get focused and stuff. So we'll see. We were really fortunate because we were able to meet for close to 11 years at Availity. It was a great space. Unfortunately, nobody that works at Availity actually goes into the office anymore. Everybody's working remotely, which is good for them. But it's bad if you're.
Why they're still holding on to the building.
They had just moved into it before COVID. Like they were only in it for like maybe a year.
I was there when they got. I was part of it.
Oh yeah.
But they haven't used it since then.
But I'm internally thankful to Availity for letting us meet there. Like 11 years. It's like with of course 3 years for COVID. But they let us meet there for a really long time. It was a great meeting space, and so I'm very grateful to Availity for letting us meet there like they did. All right, well, I'm going to go ahead and stop the online presentation. Thank everybody for coming out and attending the presentation, and we'll try to get something lined up for next month.
All right, thank you.
Thank you. Bye.